I am trying to produce music. I'm terrible, absolutely terrible at it. I think it took me 2 years to produce 2 tracks. One of them is listenable, a little bit. Okay, so we are here today, and I'm going to talk about how we can be allies by creating accessible React apps. My name is Neha Nivedita. I'm a software engineer with Node Experts, which is a global consulting firm based out of New Delhi that creates custom web apps for clients big and small on Node.js, React, Express, MongoDB, you know, the whole shebang. So let's begin. Oh yeah, I'm also on Twitter, at @nicknivedit, if you want to tweet me. Let's take a look at what we'll be discussing about today. Just a sec. Could I have the confidence monitor, please? Confidence monitor is not on. Sorry about this. I'll just continue speaking off of the screen. So we'll talk about what accessibility is, why we need it, what kind of problems we face when we try to implement things in JS frameworks, what accessibility issues occur there, how React works, and how we can make our React apps accessible. Then we'll spend a little bit of time talking about the importance of colors and React accessibility tools and unit testing in those. Before we proceed further on this, I just want to point out that this talk is meant to be a primer only. It's basically an amalgamation of what I have learned so far in a short amount of time about accessibility in React. It should help guide you on your way if you're trying to do similar things in React. It may not be perfect. None of us are. But I hope it helps you. Oh, and one more thing. How many of us were here yesterday for Justin Searle's talk? The one with 725 slides in 30 minutes. I just want to say that it makes me really happy to see that we are at a conference where we have live captioning and an amazing team of people at Whitecoat Captioning who do that. I just want to have a big round of applause for our awesome heroes who have been working very hard to make sure that this conference is accessible. And on top of that, you know, dealing with Justin Searle's brilliant, brutal talk. OK, proceeding from here. What's accessibility, and why do we need it? Everyone should be able to access any service or product, regardless of their ability or disability. This is a fact. There should be equality about this. So far, when we think of accessibility, how many different kinds of accessibility can we think of? Physical, like when people who cannot walk, they need wheelchairs, right? So this is a form of accessibility that they should have. They should be able to go anywhere. They should have wheelchair ramps. They should have buses that are able to pick them up. Similarly, we have accessibility when it comes to web as well. People who cannot see or cannot hear should be able to use web apps just as well as those of us who can see and hear. So that's web accessibility related to web services, products, and apps. Web accessibility is governed by a set of features and guidelines that help design your app to be fully usable by people with disabilities. Some of these tools include screen reader support, photo captioning, and keyboard usability. Let's look at a few terms that are associated with web accessibility. a11y. It is pronounced like this, a11y or a11y, although since I'm a terrible punster, I decided to name my talk How to Be an Ally. I like doing that. I like killing people with puns sometimes, all the time. Then we have WCAG, WCAG, that's Web Content Accessibility Guidelines. These are the rules set for how we should develop any application so that it is accessible to everyone. The third thing that we need to look out for is ARIA. It's Accessible Rich Internet Applications. These are features baked into HTML that enable any app to be accessible to people. Stats. 15% of the population has some form of disability. If we take a look at it in cold, hard numbers, that's almost 1 billion people. That's how many 15% is. Now, 8% of the population is also colorblind. Just trying to think about all of these numbers, if you try to think of exactly how many people are we excluding if we are not making sure that our app is accessible, that's 1 billion, 15% of the population, and out of these 8% being colorblind. The monitor is off again. If we are excluding 15% of our users, then we are failing at our jobs as developers. I'm sure some of us have heard this before. Accessibility is not a feature, it is a necessity. If by design we are excluding a vast number of our users, then we are actively discriminating against them, and this is wrong, this is unfair, it should not happen. Therefore, if we are excluding these many users, we are failing our jobs, and this should not happen. I'm trying to work on that myself. I did not know about accessibility for a long time, but now I'm trying to learn. So this is what I'm here for today. Accessibility will ensure that our app is usable by persons with disabilities. Today's talk is mainly going to focus on screen readers and color blindness, not so much about people who are deaf. Unfortunately, we don't have enough time for that, but let's see. So what kind of issues occur when we are using JS frameworks? Like frameworks like React, they typically use syntactic sugar to create apps. Syntactic sugar means that they're not pure HTML. Due to this, developers sometimes end up writing non-semantic HTML. Now, tools like screen readers are not able to parse non-semantic content meaningfully. What does this mean? This means that people who are disabled, who are using those screen readers to understand the content on your web page, they're not able to get any meaning out of it. They're not able to use it. Your app has become inaccessible. Let's take a look at how this happens. This is something that I'm sure a lot of us are guilty of. I know I am 10 times over. This piece of code is supposed to be a button made out of a div. How many of us have done this? Quite a few of us, right? So what happens is that when a screen reader encounters this type of a code, it fails to read it out loud as a button because it doesn't understand that it's a button. It sees a div and something inside it. That's it. That's all it sees. This way, the user is not aware that what they're trying to look at is actually a button. So if we try to look at it this way, you could say the verdict is that because of JavaScript frameworks, these frameworks are killing accessibility. But it doesn't have to be like this. Let's take a pause on that thought and think about how React works. React works with DOM and virtual DOM. Whatever changes we want to happen in the app, they occur in the virtual DOM. And the React reconciler compares the difference between what is already there on the screen and what the changes are supposed to be, and updates those differences on the actual DOM. This is an example of React JSX. It looks like HTML, but it's not HTML. It has a label, but then it has certain attributes that are written in camel case. You can pass values to it. So this looks like HTML, it might be. React JSX is then converted into pure HTML and rendered in the DOM, just like that. So if we try to think about this, we can say that essentially whatever code we are going to write, it is going to turn into HTML at some point. It's going to be plain old HTML. So if we start writing semantic HTML, our code can by default be good with accessibility. So if any of us have been holding on to the excuse that, hey, look, I'm a React dev, I'm an Angular dev, therefore accessibility is hard for me. No, it's not. It doesn't have to be. Yes, it will take some effort, but we can do it. React supports ARIA natively, so therefore use it properly. Write good React code, then you get good HTML code. If you get good HTML code, then you have better accessibility. Simple as that. How to make our React app accessible? I'm going to take you through a series of several types of actions that we can take to do this. React provides several features that make accessible design possible. First of all, before we begin on that, we need to make sure that we get the low-hanging fruit out of the way first. If you need to show an image, make sure that it has an alt attribute. Alt attributes are important to screen readers. Do not make a button out of something that is not a button. Don't use divs for that. Don't use anchor tags. I'm going to keep coming back to this point again and again until I'm sure that we've got it. Write semantic HTML. Let's take a look at the core accessibility features we can focus on. Setting page titles. Setting page title is important for several reasons. In a single page application like React, the page may update. We may go to a different route, but then the page title remains the same. This creates problem because the page title is the first thing that screen readers usually read out. Now, if a screen reader isn't reading out that difference, then a user may not be aware that something has changed, that we are at a different location. So let's update our page title in a React app. We can do it simply like this. We can update the document.title inside our component did mount lifecycle method. Simple as that. Or we could use some plugins for it. There is React document title that does the same thing. You wrap this component around whatever content you want to render and provide it a page title. Or you could use React Helmet. This is a very useful plugin that is used not just for setting page titles, but also for basically setting anything that you want to on that page's HTML head. You can include meta tags in it, so it's very useful for SEO as well. Header semantics. So some of us may have used headers in ways they were not supposed to be used. How many of us have used headers just to set something like font size? Some of us. Make sure that you're using headers the way they are meant to. Headers basically define the structure of your content, where sections are supposed to be, which is a subsection, and so on and so forth. The top header should always be h1, followed by an h2, and then an h3. Don't try to use headers if what you're looking for is font size in CSS. Never do that. If you did that in your school homework for English, your teacher wouldn't approve, so no need to do that now. You can also create configurable header component like this. You can pass it content as well as level of the header, and it will spit out the correct header tag. You can also configure it to return next level header programmatically. Unique IDs. Unique IDs are again important for screen readers because they specify exactly what element a screen reader is focused on. To generate unique IDs, you could use something that comes from a database, or you could use a library like UUID to generate unique strings so that the screen reader knows exactly where element is supposed to be and your user is able to parse through your content meaningfully. React fragments. React fragments, they were introduced in React 16 a while back. They are used to group a list of elements without adding extra nodes to the DOM. They do a very useful thing in that they get rid of invalid wrapper divs. Let's take a look at how we used to export certain components that had sibling elements but nothing wrapping them. We would have to add an invalid empty wrapper div around it just to export it as a single component. Now, if we did this on something like a list item or a subset of list items, if we try to export that, it would not come out in a way that was semantically correct. There aren't supposed to be any divs inside an unordered list unless they're inside the list item. So what to do about this? Use fragments. Since React 16, you can use React fragment to wrap such items and export them. So when this renders in the DOM, it is not bound by any empty, useless, invalid wrapper divs. Your code is semantic, perfect, and ready to be read by a screen reader. Change announcements. What are change announcements? In React app, since React is dynamic, things may be updating at any section of the page without being picked up by the screen reader. This creates a problem. When something is changing, we want the user to be aware of it. For this, we can create a simple component that makes use of the ARIA live attribute. What does ARIA live do? Whenever the underlying content of an HTML element with the ARIA live tag changes, it announces that content again. So here, we are doing something that basically creates a simple, empty component that can be put anywhere in our app. Inside it, we can put a message. At first, the message can be empty. And when we want the announcer to announce something, we can simply pass it some message. Since it has the ARIA live attribute, the screen reader will pick this up and announce it. You can see that the ARIA live value right now is polite, which means that the screen reader will wait until any other announcements have been finished to announce this one. ARIA atomic true means that whenever any part of the content inside this component changes, it will announce the entire thing all over again. How to use this? In any parent component, have a value in the state, like message. At first, it's empty, it's null. Then when some event occurs, set the state to what you want it to be. Like Professor Eutonia might say, element X has been added by mistake, but whatever, it will create the Powerpuff Girls. So this value can then go into the announcer via the state, and whenever the value changes, the screen reader will pick this up and announce it. Pretty simple, but very useful. There are other components like this as well that you can use. There's React ARIA Live and React Accessibility Announcer. Both of these do the same thing. There's also something called React Portal that was recently introduced. React Portal is something that is not exactly part of your current React DOM, but it is outside of it, but you can still access whatever values inside it. So this could be potentially used for an announcer as well. Focus. In life, focus is important. This is what I've been told many times by my parents, by my teachers, by some friends. I never used to listen to them. I'm terrible at being focused. But this is, again, very important when it comes to accessibility. What does focus do? When a page loads and we want some element to be focused by default, that thing is important when we're dealing with JS frameworks like React. React, so far, has silent routing. That means that when the route changes, nothing much happens. The browser doesn't refresh, so keyboard focus doesn't really know where to go by default. So you need to manage it on your own. For this, you can use refs. Don't overuse the refs. Use them judiciously, but for managing focus, you can use them. Since React 16.3, using refs has been more straightforward and easier, you can use them like this. For any component, you can create a ref using react.createRef. As you can see in the constructor over there, we have a ref called section header. And then in my render section, I have a h3 tag, which I want to be focused. So what I'll do is that I'll attach this ref to the h3 tag. Next, when this component mounts, I want the focus to go to that particular ref. So what will I use? I will use a component didMount method, and I'll look for that particular ref, section header, and use .focus to make sure that when this component is mounted, that header is being focused. Now, when the screen reader notices that this particular component has the focus, it will read out its contents, and it will be easier for the user to know where they are. Like we discussed earlier, let buttons be buttons, for God's sake. Always remember this. Again, this is not just about buttons. This could be about any element in HTML. try to use semantic HTML as much as possible. Don't try to repurpose some type of HTML tag for something it was not meant for. Use anchor tags for links, use button for buttons, use tables if you need to. That example that we saw earlier, the button with the made out of div, don't do that. Use a button, attach an on-click handler to it. If you want it to look like something else, if you want your button to look like a anchor tag, use CSS for it. But don't use anchor tag to make it. Next, let's talk about SVGs. SVGs by default, they're not parsed properly by screen readers. But still, SVGs are better than PNGs if you want to use icons. This is especially important for people with low vision who might need to zoom in on their screen to see, to read what's in there. Now, since SVGs scale better, if you zoom in on it, it won't break, it won't blur, it won't be, what's it called? Basically, you can understand what's in there. But with some PNGs, if you zoom in too much, you might not be able to see what's in there. You might not be able to understand. It's too blurry. So how to make SVGs accessible? You can use the title and description tags that are supported by SVG. Screen reader do read this out. So make sure you have this whenever you're using SVG. Here is an example of how to do it. I think I picked it off W3 website. Anyway. So this SVG has a title and description. Screen reader will read it out, and the user will be able to understand what they're looking at. Context is key. Context is super, super important, no matter what you're doing, where you are, especially so in accessibility. Take a look at this icon over here. It's a common enough icon, it's a cross. Sometimes it means close, sometimes it means delete. You need to specify exactly what the purpose of that icon is in the context you're using it. If you don't do that, it's like Apple and Apple. One of those is super popular. The other one manufactures fancy laptops, right? So make sure you specify the context when you're using icons, be it SVG, PNG, whatever. Add custom titles whenever you can to provide contextual info to screen readers, and make sure that you can do this for any type of element. You should know this. Next, colors are important. That can also be a problem. Typically, when we design our web apps, we put a lot of stock in colors. Hey, it's green, right? That means success. That means save. It's red. That means error. It means delete. Blue is for info or for update. The problem begins to happen when we begin to rely solely on colors to provide meaning. That should not happen, because colorblind people are going to have a very, very, very tough time with it. You don't want to trouble them so much. Another type of problem that occurs when we are using the wrong colors is when there is less contrast. People with low vision cannot differentiate between two colors that are of same hue, and the contrast between them is very less. So you might think that you have a very visible pale red background and a dark red foreground, but someone with low vision may not be able to see anything on that screen. You don't want that to happen. So choose your colors wisely, and try not to put too much stock or too much meaning into the colors. Sure, use that, but make sure you provide additional info. You provide the contextual information along with the color to make sure that your user understands what is happening, what they're doing, what they need to do. Pair the color with text or descriptive icons that the user can easily understand and use. And ensure high contrast between element background and foreground. Now, time for some opinion. Accessibility benefits more people than you would think. When we talk about, or when we think about physical disability, when we talk about places being accessible, when we even think of the dips in the sidewalk that you see, are those being used only by people who are physically disabled who are on wheelchairs? Or are they also being used by other people, parents with babies and strollers? older people, older people with low mobility, people like me who still likes to walk down that dip, even though I can step aside and. The point is not that. The point is don't exclude anyone if you can. If you start thinking of accessibility like a feature, then you are by design excluding people, and that's harmful. So when we talk about web accessibility, if our apps are accessible, that does not just mean that people who are blind would be able to use it, but think of older people who have a tough time trying to memorize the newer interfaces that we come up with every day. They might be able to grasp it better, more easily, if they're using the accessibility options, increasing the font size. They might have an easier time with it. So try to keep that in mind. It might seem like a lot of work at first, but somebody said to me that once you get into the flow of it, once you start writing your code semantically, it gets very easy. And you just start doing it without thinking. So that is something where we need to get at. And for that, we have several accessibility tools as well that will make our life easier while we are trying to get there. Since I don't have enough time, I just want to very briefly dip into unit testing. What are the kinds of things that we should test when we are developing React apps? We should test whether our ARIA attribute values are being set correctly, whether our page title is being updated correctly, whether our elements are being focused when and when they should, whether our announcers are working fine. Everything apart from this should be caught in the linter. Here is a very simple unit test example. Here I have a React component named button, which has a label called close. In this test, I'm checking whether the underlying HTML button has the ARIA label property set correctly or not. This will ensure that the screen reader is able to read the value of this button correctly. So you can think of more tests like this. Time for tools, dev tools for accessibility. We have several libraries, take your pick. We have ESLint plugin for accessibility in JSX. It's a very cool, useful linter that will tell you where you're falling short, what you should do, and what things you should correct in your code. We have React Accessibility Analyzer and React Axe, which throw errors into your console so that you know where things are going wrong in terms of accessibility. If you're a beginner and you want to start into this but are not sure where to begin, the Create React App repo by Facebook is a very good starter. It also comes with several accessibility options configured, so it would be a good place to start. And then there are several accessible modules available at this link over here, react.rocks/tag/accessible. There are several other tools that you might be able to use when you're developing your app. There's Chrome extension called C. This is a very cool, very useful one in which you are able to see your app from the perspective of a colorblind person. You are able to see it the way a colorblind person would see it. And it really, at first it can be really jarring, but also it should generate a lot of empathy. And then you'll be able to understand better and write better code, design better apps, and make sure that whatever shortcomings you have in your code right now, those are removed. Then there is another tool called Contrast Checker. It will help you decide whether, help you discover whether the contrast in your app is fine or not. And finally, the React docs on accessibility are very useful. I have read from them personally, and I found them a good place to start with. All right, so that was my talk. Thank you for being here today. Please follow me on social media. That's my Twitter handle over there, Nivedita. Email me if you want to talk, want to say hi or have questions, want to yell at me, feel free. That's hi@nivedita.in. And please also visit the Node Experts website, nodeexperts.com, and check out the cool things that we have been doing. Thank you so much, and have fun.